Hello everyone, I'm teacher Winnie. Today we will do the paper on this SBP paper 1 for Physics SPM Trial 2024. So the first question, what is the imperial unit on a pressure gauge? So for your information, in the first topic itself in Form 4, you all learn about the difference between imperial unit and also metric unit. So most of the unit that we commonly use nowadays is actually metric unit, like in length meter, okay, and then a volume meter cube, time second, temperature Kelvin, all this, right? So and then pressure is generally Pascal. So for information, Pascal, Newton per meter square, they are actually same thing. So what is the imperial unit for pressure gauge? It's actually PSI. So it's also in the textbook lah, right? Okay, imperial unit. Pounds per square inch. So inch square inch pounds, all this is actually imperial unit. Okay, so in case you're having other questions that involving length or mass, so you have some idea on that. Okay, question 2. Which diagram show the best graph? Okay, so when you plot graph, first thing you all need to choose the scale which actually can occupy the size of the graph, right? The graph size should be about 70% of the graph. So as you can see, A and B, they only use half of it, or the point that plot. So that's why this is not correct in terms of the idea of size. So once you all choose a correct scale where they can occupy about 70%, the next thing is you all plot the point according to the value given. Then you're going to draw the best fit line. So the difference between C and D is the context of best fit line. So in terms of size, they are same, agree? Now, let's look at C. So if you can see, right, it seems like this line don't touch any of the point. But they don't touch any point, right? The point that above this line is 1, 2. There are 2 here, correct? And then beneath the line, there is 1, 2, 3. So the difference between the points is actually 1. So whenever you want to draw best fit line, right? So the difference must be either 1 or 0. Now we look at D. D. Above you have how many points? 1, 2, 3. Beneath you have how many? Beneath you only have 1. Then this one is what? Touching. This one touch. So not counted lah. So what is your difference now? Your difference now is 3 minus 1, which is 2 points. So this is not a best fit line. So for information, why we draw best fit line? So that the line that you draw seems to be your average. And then all the points must be distributed evenly lah, above and beneath the line. Also, the answer for this question is C. Number 3. Diagram 1 show the displacement time graph for the motion of an object. Which velocity time graph describe the movement of the object? Okay, so how do we transform displacement time graph to velocity time graph? So I always tell students, in motion graph, if you want to describe the idea clearly, you always related it with the idea of gradient. Okay, so what is the gradient of graph? Displacement time graph. So gradient is actually displacement per unit time, which is referred to the idea of velocity. So whenever you see the graph, there is a line with a gradient. That means they have velocity. And not only they have velocity, the velocity is supposed to be constant or uniform. So when we transform in velocity time graph, constant means all these quantity have to be no change. So it will become horizontal line like this, or this, or even this. Okay, so the first part, A, B, or D possible lah, but then this one wrong already. But then the next part, this become horizontal. Horizontal means, do you have any gradient? No, right? So your velocity is supposed to be 0. No gradient. Okay, so this one go downhill, so not so accurate. This one increasing, also not accurate. So for information, this line under velocity idea is also means constant deceleration. Okay, and then this one is actually constant acceleration, because the gradient for velocity time graph is what? Okay, gradient for velocity time graph now is referred to acceleration. Acceleration. Okay, because acceleration is v minus u per unit time. Okay, then this one you got is constant. So memang C is out already. So 0 is here. So in a case, paper 2, you all need to draw graph all these. You all need to show the line as well. So hopefully you all have some idea how to draw motion graph. Next, number 4. Diagram 2 show the value of gravitational acceleration at the North Pole and the equator of the Earth's surface. So which statement is correct to describe the difference in the value of G? So obviously on North Pole, what happened to the value of G? GF North is actually 9.83. Then equator is 9.78. So it's more than the value of G in equator. Okay, so now we try to see the Earth is spherical, cannot log, because if spherical, then the value should be the same, right? So not accurate. Okay, then next, the gravitational force at North Pole is smaller than at the equator. Okay, so what is the formula for gravitational force? Or in short, is actually W equals to mg. So generally, if your value of G is higher, your weight should be greater. That means your gravitational force also will be greater. So, but then here they say smaller wall. Okay, so that's why this idea is also not correct lah. Okay, because at the North Pole supposed to be bigger as well, Next, C. The North Pole region is covered with snow, which make the density of the polar region lower. So it's not related to the idea of this value of G. So not related. And then lastly, the distance from the equator to the center of it is further than the distance from the North Pole of the center. Okay, so of course, the question they didn't directly give you about the diameter or distance or radius, right? But then based on the formula that you all learned in chapter 3, value of G is what? You can have one formula. You all can refer the formula list. Okay, this G is Gm over R squared. So they talk about equator first, right? So equator, so the value of G on equator is lower. So what do you think the radius or the distance, okay, is supposed to be greater, right? So correct already, the distance from the equator to the center of Earth is further. So the answer for question 4 is D. Number 5, diagram 3 show an astronaut walking on the surface of the moon. What will happen to the inertia of the astronaut if the astronaut walk in the same suit on the Earth? Okay, now this idea related a bit on the idea of weight and also a bit idea on the inertia concept. Whenever we talk about inertia, we relate it with what? Mass. Okay, and then the higher the inertia, the higher the mass. Okay, but now they are talking about the astronaut on different surface, right? On the moon and also on the Earth. So for information, mass will not be affected by position. What is affected in 2.8, you all learn about mass versus the concept of weight. So astronaut will only have different weight when they are at different surface, like on moon, they will be smaller due to the value of G is small, right? So that's why the content of mass doesn't change, doesn't change. Okay, so inertia and the mass have the directly proportional. So if mass unchanged, inertia also unchanged. So that's why the answer is C for these questions. Number 6, diagram 4 show a 0.025 kg bullet is fired from a 1.2 kg pistol, and the velocity of the bullet is 200 meters per second. What is the momentum of the bullet after being fired from the gun? So for information, this idea is under principle of conservation of momentum, and the concept involved is actually the explosion idea, explosion. So from the idea of explosion, you're supposed to know initial before fired, the gun and the bullet is inside one. Are they moving? No. Also, the total momentum is before is 0. And then they will be equal to the final momentum, which is m1 v1 equals to at plus m2 v2. And then when you all rearrange the equation, you will have M1 V1 equals to negative M2 V2. So from the concept of explosion, right? Most of the application is under explosion. So it's actually telling you that the momentum of one of the object, the magnitude should be equal, but in opposite direction. That means after you fired, right? After you fired, the bullet will move forward, but the gun or the pistol will move backward. So for information, the momentum of the bullet should be equal to the momentum of the gun. Okay, so be careful about these questions. Most of the time, general idea, we want to find what? The velocity, correct? Like example, what is the recoil velocity? But these questions, they want the momentum of the bullet. So I do not have the velocity. Also doesn't matter. Also, what is the idea that you all use? I want the momentum of the bullet only, So do you have the mass of the bullet? Yes. Do you have the velocity of the bullet? So generally, the P for bullet is actually mv equals to 0.025 times with 200. Okay, so this question is actually wanting you to find the momentum only, that's it. So therefore 0.025 times 200, you're supposed to get 5. So what means is you all don't confuse with the idea whereby generally equation want us to find velocity. So be careful a bit and the unit kgms negative 1. But just now teacher actually elaborate the concept of explosion. Okay, so same like rocket, okay, your upward momentum should be same as the downward momentum of the exhaust gas, and a lot more of applications. Question 7. Diagram 5 show a stroboscopic photo of a golf performing a follow-through action. What is the effect of follow-through action? So I will tell student, follow-through action can apply the concept on impulse. Okay, so what is actually impulse? So impulse symbol is J. J impulse can be force times time or rate. Change in momentum. Change in momentum. They are same thing lah. Okay. So generally the idea behind it is what? When you swing it, right, you will take time. So indirectly you will increase the impulse. When you increase the impulse, it means your change in momentum will actually increases as well. Okay, or you actually increase the final velocity. That's why at the end, the golf ball can travel further. So A, small velocity of the golf ball, not correct, Zero change, not correct, Teacher already said you have a higher final velocity. Large change of momentum, yes, okay, because I mentioned already the whole thing have to be higher changes, this idea And then large rate of change, wrong, Rate of change of momentum is referred to impulsive force. So in this context, we don't involve the idea of impulsive force. If you want to involve the idea of impulsive force, is the moment the golf ball touch the ball straight away. Understand? The golf cup touch the golf ball. So in this context, they don't involve this idea. If yes, yes, they have to hit it with shorter time and increase the force but this one is the idea of you swing it, like you play tennis ball, so you swing it. Okay, so the answer is C. Okay, number 8. What is the factor that affect acceleration? Okay, so you all learn under the Newton's second law of motion. So you all know that what? F equals to ma context. So generally acceleration is affected by what? These two idea law, mass or force. So power not related, energy not related. So the answer is A. Number 9. What is the definition of gravitational field strength? Okay, so for information, gravitational field strength is force per unit mass. They have the same unit as gravitational acceleration. But generally, the slight difference is gravitational acceleration will involve when object is falling. when free fall happen. But gravitational field strength based on textbook is actually force per unit mass caused by gravitational pull. In short, I will tell student the formula is force per unit mass or unit. It can be Newton per kg. Okay, so we see all this option, the correct answer is A lah, because this one is per unit volume acceleration density is a wrong concept already. Question 10. Diagram 5. Show a force act on a carousel swing when the swing move in a circular motion with a linear speed. So what is this force Q? So for your information, like cowboy also, when they swing a string, okay, you know that the object will keep on move toward the center of the object. So the force involved is actually called what? Centripetal force, centripetal force. So what is this centripetal force? It's a force that acts on the body in the direction towards the center of the circle. 11. Orbital radius of Venus and Neptune orbiting the Sun are 1.082 times 10 power 8 kilometer and 4.497 times 10 power 12 meter respectively. And given that the orbital period of Venus is 224.655 days, calculate the orbital period of Neptune in the unit of days. Okay, so this idea is under Kepler third law, where Kepler third law say what? The square of the orbital period is directly proportional to the cube of the radius. Okay, orbital radius. So under this Kepler third law, you have a formula one, which is T1 square over R1 cube equals to T2 square over R2 cube. Okay, so we're going to apply this formula lah. Okay, so I always tell students, if you're not good in maths, okay, then you always make the top part as subject. Top part as subject. So generally they want you to calculate what? The period. Okay, you can make the equation not so confusing by what? Okay, because the 1 and 2 is up to you to label one. So you can also do like that. You can assume 1 is Venus. Okay, then 2 is what? 2 will be Neptune. So you put it as N, something like that. Then same thing. When you do so, you straight away also all the number on top, straight away put the quantity one. So that means this one you put TV. And then you put, sorry, this is not T, my bad. This is R, radius. Okay, so this is R, V, this is R, N, so that you will not sub wrongly. Because sometimes you all don't label all this. When you put in the value, you will accidentally put the balik. This means if you the balik kan, the Venus and Neptune, then everything is wrong. Then this one is TV. So they want me to find TN. So this is the subject now lah. So I always tell students to rearrange the equation first. So Tn square is the subject now. So how do you all rearrange? People who don't like maths. So this one you bring up. And then I normally want student to put same quantity together. So the whole thing you can bracket and cube it all. So in terms of the maths idea, you will have less problem. Then actually this one you put up already, actually you still time with TV square lah. Now you can arrange the equation until like that. Very good. Then the next step, okay, you all put the number in. Okay, so put correctly lah. So what is your Rn? 4.497 times 10 power of 12. Okay, they're a bit naughty in these questions. Why? You see your RV. Your RV, are you writing 1.082 times 10 power 8 only? Then you'll be wrong. You careful. You have the kilo here. Kilo is 10 power of 3. 10 power 3. So that means you need to write 10 power 3. Or people who good, you can straight away 8 plus 3 lah for your understanding. Then you divide this in calculator. Then the whole thing only you cube it. Then finally you time is what? 224.655. The whole thing bracket and square. So for your information also, a lot of students always cannot get accurate answer for this chapter is they accidentally forgot to cube lah, forgot to square lah, or at the end, you solve the whole thing already. This is still not the answer, you know. So what it means, you press everything, this is still under Tn square. I not yet square root the final answer. Get the idea? So that's why you all need to really do everything lah. So if you press calculator, all must try one. That's why I always say, sometimes you listen to my explanation now, macam senang, can do, okay, understand the formula. But if you don't press calculator, the hard part is what? You still cannot get the correct idea is because you do not press calculator, not because you don't know this formula already. Okay, so you square root of it, and then you get the answer. Okay, so the answer may perform in this idea in the whole number one. So 60194.87668 days. Okay, now the answer given here is in standard form. So people who don't know how to change to standard form, okay, this is a big number. So you move the dot 1, 2, 3, 4. Okay, so it becomes times 10 power 4 lah. Okay, so this is close to B law. The answer agree. Okay, now in paper 2, you all can leave your answer in this one. Okay, but make sure you all write the unit lah. So you no need to change to standard form if you do not know how to change to standard form unless the question requests. But then objective question normally the requirement they like to be everything in SI unit. Then next thing is they sometimes will perform the answer in standard form like what you see now lor. Question 12. Diagram 7 show hot water is being poured into a cup. Which statement is correct about the flow of heat? A. Net heat transfer is 0. B. Heat flow only from the hot water to the cup. C. Heat flow only from cup to the hot water. D. There is a net heat transfer from hot water to the cup. So generally for understanding, when the hot water is inside the cup, they will actually have thermal contact water inside, okay, with the cup. Okay, so there is a heat transfer from the hot water and also the heat transfer from the cup back to this hot water. Okay, and the heat from the hot water to the cup is greater or higher. That's why we say there is a net heat transfer from the hot water to the cup. So the answer for D is the correct idea. The net heat will not become 0 yet until they say when they reach thermal equilibrium. Okay, like I say, the heat is in both directions. Notice my arrow head for the purple color and red color. So that's why B also not correct. C also not correct. Okay, they actually also transfer heat. It's just that one is greater than the other. 13. Diagram 8 shows a pan used to cook vegetable. What is the suitable characteristic of material to be used for the bottom surface of the pan? Okay, so for information, you want to cook food. So we always relate the idea of cooking utensil with the concept of specific heat capacity. So I will tell students, specific capacity is fixed for the material or all material that have their value of this specific heat capacity, in short C symbol. So I will say if it's low, then it's act like heat conductor. That means they will absorb a small amount of heat, then they can increase the temperature a lot. If the value is speed that is higher, that acts like a heat insulator because you absorb a large amount of heat, then only increase the temperature a little bit. Okay, so generally the characteristic is low specific capacity because it is heat conductor, right? The bottom of pan. And then they're supposed to be a high melting point, and if high melting point, so that's why low is wrong, low boiling point also not correct, low thermal conductivity also cannot. 14. Diagram 9 shows air bubble, which are formed by a fish. Which of the following is true about the depth and the liquid pressure in the position X compared to Y? Okay, so the MMR involves two contexts. One is under gas law, and then another context is under liquid pressure. So gas law idea, teacher will say you use this PV, T, and then the three respective side is actually the three different law, right? Okay, Guru, Bahasa, Shina. So in this context, this is on Boyle's law, where they involve the idea of pressure and volume. So generally, they are inversely proportional to volume. But then now they are talking about depth and liquid. So they actually are more towards the idea of liquid pressure idea in Form 5. But then because in the diagram, they show you the gas bar. So you see your volume is increased. That means your pressure at X is lower. Why pressure at X is lower? What happened to the depth? So depth is always measured from the surface of the water to the point. So you see this point, the depth is less, right? Depth of X is less. This one, you see the depth is, and Y mark, is higher. So everything for X is lower. So the answer is D. Okay, number 15. 50 is under wave topic. So diagram 10 shows the wave pattern produced by the continuously dropped water droplets. So which 2 points represent the wavelength? So firstly, you all need to know what is wavelength lah. Okay, so water wave, you have now I show you all 2 dimension, easier to capture a bit. So you have the point like they label here. Okay, this point is all called what? Crest. And then you also have the point at the bottom one is called what? Trough. So generally, what is a wavelength? Wavelength is the distance between 2 consecutive points which are in phase. 2 consecutive. So it means side by side. So based on what I label, is more obvious. It's either from the one crest to the next crest or from one trough to the next trough. So based on this diagram, which one is side by side one after another? P to S is a bit far already. RS is a bit too short, okay? Means half of them, right? So it's from one crest to the next crest. So that's why the answer is what? The answer is C. Okay, then move on, number 16. Diagram 11 shows bottom pendulums when the pendulum Q is displaced and released. It was found that the other pendulum is also swing. Now, which pendulums A, B, C, and D will swing with maximum amplitude? Okay, so this concept is under the idea of resonance. Okay, resonance. Okay, so how resonance basically occur when they will have same frequency. Okay, the driver pendulum will cause a frequency which is the same as the natural frequency of another object. Then what happens is they will swing with maximum amplitude, and therefore resonance occurs. So you see among A, B, C, D, which one is have same common idea with Q? Is the context of length. So the length of this Q is exactly the same as which one? Sorry, exactly same at the D. Notice or not? So they have same length. That's why they experience resonance. Okay, so they will swing with maximum amplitude. So for this question, the answer is B. 17. Diagram 12 shows a water wave propagate toward a black wall. Which physical quantity will change after the wave is reflected? Okay, so I will tell you all under the phenomenon like reflection, refraction, diffractions. Also, they always want to see what will change and what will not change. And I will show this table. So for diffraction and refraction, they are same. Frequency, no change. Wavelength, no change. Speed, no change. Only direction, because after the wave strike the surface, right? Okay, so I lengthen this line. So generally, what y'all should do is you're supposed to draw normal line, okay, which is perpendicular to the surface. And then they will actually bounce, okay? So direction have changes, you see? Direction changes. But then wavelength, speed, all this will be constant. So the answer is C for these questions. 18. Diagram 13 shows a wavefront produced when it's propagate through a gap on the seashore. What is the wave phenomenon shown after propagate through the gap? So I know that this diagram is not so clear. Okay, so basically here got a gap. So the wave coming out look like this one. Okay, so actually generally the wave have been spread out. So this concept is called diffraction. Diffraction is the spreading out of the wave when it passes through a gap or around an obstacle. 19. Diagram 14 shows a pattern of light fringes produced on the screen in young double slit experiment. The separations of double slit used is 5 times 10 power negative 4 meters. Screen placed at distance 2.3 meter from the double slit. Calculate the wavelength. So this idea is under interference of light wave, where under wave topic, you only have a few formula, right? So under interference is lambda equals to AX over D. So you all really need to know what is A, what is X, what is D, what is lambda. Also lambda is referred to wavelength lah. Okay, so what is A? A is the distance between two double slit. So this is actually A idea. Then D is the distance from the double slit to the source being measured, okay, which is 2.3 lah. And what you see here is the idea of X. But here there are not only one X. How many X here? 1, 2, 3. So the distance between two consecutive bright fringes is called X. So here you have 3x equals to 9 times 10 power negative 6. So that's why you find out what is x first off. 3 times 10 power negative 6 meter. Okay, now you have all the idea already, AXD. So now you sub into the equation. A is 5 times 10 power negative 4. And then x is 3 times 10 power negative 6. D is 2.5. Press calculate. And then you will get 6.5. 19. Okay, if I'm not mistaken. So let's press again. So like I say, whatever calculation, you all don't just listen to teacher. Take out your calculator, do it now. Okay, it's just not taking more than this 1 minute one. Okay, but you got syntax error, all this. That's means the way how you press calculator tak betul lah. Yeah, 6.52 17 times 10 power of this negative 10. You need to see calculator also. The power is on the right hand side on top there. So that's why this is how you all know. Now this question is direct, whereby all their unit is all in meter. So you no need to worry about the prefix idea. But I will say in which chapter you all need to remember all these basic prefix: centi, milli, micrometer. So what is this centi, milli, micro? Centi is 10 power negative 2. Milli is negative 3. Micro is 10 negative 6. So at least you take notes, okay? If you all see this prefix, you have to change it to without prefix. Then only you will have the accurate answer. Because normally they want SI unit, so they're supposed to leave the answer in meter. But then if the answer is in centimeter, then only you do normal math. So you change the meter into the centimeter idea. But student who good in maths, is okay, up to you. You can change everything in cm, then you sub, and then you get the answer. But student always a bit weak in maths, conversion of unit, all this, you follow what I tell you, then you will have less mistake. 20. Which statement is correct about the properties of electromagnetic wave? So for information, what is electromagnetic wave? Is a wave whereby the magnetic field and the electric field, which are perpendicular to the propagation of the wave directions. So they are actually classified as transverse wave. Okay, they have the speed of light, which is 3 times 10 power 8. And then they no need medium to travel. Okay, so which statement is correct based on my explanation? Longitudinal round radial, I say they are transverse. Speed of EM wave is same as speed of light. Yes, okay, correct. They only consider magnetic field. Wrong. Okay, it's magnetic field and electric field. Then require medium. Wrong. Not require medium. 21. Diagram 15 shows a light ray propagate from air into the glass block. Which path is correct? So as this is idea of refraction. So when the ray travel from air to glass, they actually slow down. When they slow down, the ray will generally refract towards normal. Understand? Then you always need to draw the normal line again. So what is this normal line? A line which is at 90 degrees to the surface, at 90 to the surface. Okay, then when they're from glass, they travel back to out to the air. So same thing, from denser to less dense now, the ray will travel away from the normal line. Okay, so when you finish drawing, right, you should have some idea because outside is still air. So this angle and this angle is supposed to be same, the emergent angle and the incident angle. So that's why I is the answer. C, memang is wrong already. You did not have the ray that bounce like that. Okay, So in terms of drawing A and B is correct, but the location of theta is wrong for B. 22. Diagram 16 show a turtle swimming in the water, and it was found that the image of the turtle was formed at the boundary of water and air, which light phenomenon formed the image. So this idea is called total internal reflection. So as you can see, the picture is again not so clear, it's here. So this is the turtle head and body. So same thing. So this is the, this is a turtle hand, head, then turtle hand. So it's like a mirroring like that, but then they actually reflect inside the water. 23. Telescope is an optical device that use two convex lenses to see distant object. Why convex lens is concave lens not used in telescope? So this is convex. This is the idea. So again, if you're memang got the concept on telescope, and you are my student, or you follow my idea, I always tell you all under the ray diagram, for convex lens, you have 6 characteristics, right? Boom, boom, rim, red, okay? And I also classify them as case 1, case 2, case 3, case 4, case 5, and case 6. So to construct the ray diagram for telescope, we are using the idea of case 2, and then later on, when the image form here, then you will draw case 6 punya idea. And finally, your image is formed, final image is at infinity 1. So your object is at distant object. Hey, sorry, I terbalik already. It's case 6, then only case 2, okay? So like star at infinity, all these are far, you cannot see one. So you want the image to form here. Case 6, the characteristic is real inverted diminished. So generally, convex idea will enable you to have the real image. Okay, of course, again, students who have idea regarding the image formed by concave lens, their image is always virtual upright diminished. So if you read through all the options, right, inverted and magnified is not true already one. So A and B, which one is a best answer? Okay, so for information, we want the first image form after the lens. So it need to be real. If they are virtual, that means your image will be formed somewhere here. Then what means the function of the objective lens is not there anymore. Telescope must have both eyepiece and also objective lens. So that's why A is the best answer. A is the best answer. 24. A candle is placed in front of a concave mirror which have a focal length of f, and it is found that the image form has the same size as the objects. So what is the object distance u? Okay, so to solve this question, same thing. You all need to know how to draw the ray diagram for concave mirror. Okay, so concave mirror, this is how it look like. Curve inward one. Okay, and then I always tell students you have the focus point, you have the 2F, which is in mirror, sometimes they call it as center of curvature. So you have the 4 idea, 6 idea, okay? Case 1, 2, 3, 4, okay, at 2F, then 5, and then at infinity. And then teacher always say one, okay? The characteristic, if you really draw out the characteristic, so you have boom, boom, rim, wrist, rig. So they want what? Same size, same size as refer to the same size. M is magnified, D is diminished. So case 4, that means your object must be at where? 2F, exactly at 2F. So that's why if you all know how to construct ray diagram and remember this thing, then you are easier to capture the idea whether for convex lens or concave mirror. Okay, 25. Diagram 17 shows a car applied with force F and move with uniform velocity. So what is the magnitude of force? Okay, so for information, when object move at constant velocity, uniform velocity, the concept, your resultant force supposed to be 0. F net is 0. Okay, net is referred to resultant. So how do we get resultant force 0? The idea of your force applied and the frictional force, in short, must have same magnitude but opposite direction. So I will tell students, when object at rest, the net force is 0, all of you okay. But then sometimes students confuse why F net is 0 when They move at constant velocity. So we go back to Newton's second law of motion. Memang this is the equation that apply. So you see when the velocity is constant, do you have acceleration? So your A is 0, what? So that's why you get 0. So that's why constant velocity also can have this idea. So therefore, your value of your frictional force must be equals to the thrust lah, the forward force. So they say what happened to the F ma, right? So 0 wrong law, equal to frictional force. Yes, less than frictional force, no. Higher also no. If they are less than frictional force, that means they will encounter deceleration. If higher, then they will encounter acceleration. 26. Diagram 18 show 3 forces P, Q, and R acting on a foul port that is hanging stationary. So which diagram represent the three force? So I will tell student, you all need to know the free body diagram under the topic of forces and motion 2 in Form 5. So the Q is the tension caused by the weight downwards, and then you have this R and also P. So they memang want you all to rearrange these 3 forces again into a triangle. So when you all rearrange back into the triangle, you're not supposed to change the direction of the arrowhead and the angle. Okay, so I will tell students is like you playing 2 pigs or like your matches. You just move against the whole idea. Of course, the line can be lengthened or shorter depending on the context lah. So generally, you see, if I were to move like that, you see, I can form a what? Triangle. Then you see my arrowhead, all the arrowhead must follow one, like this, in a circle. So why the arrowhead facing same direction, either clockwise and clockwise, that means your resultant force is 0. They are in the state of equilibrium, okay? And the name, you cannot change, So this is Q lor, the downward one, right? Then P is this one. Then R is this one. Okay, you see, the arrow macam betul, but then P is not the idea of Q ma. P is going up ma. So that's why C is not right. Okay, so based on what I draw, memang the answer is A lah. A. Then B, why wrong? Your R is facing this way ma. Where got facing down, so tak boleh juga. So that's why the shape correct, the arrowhead correct. You also need to see are the label of the all forces same or not. 27. Diagram 19.1 show 2 springs with different original length. Okay, means I name them as spring 1 and spring 2. So spring 1 is shorter, spring 2 is longer. Then 19.2 show the wood is moved to the wall by the force F. Okay, then they will actually compress the spring until they are at T, So for your information, when your move is here, when they reach S, right, they are actually pushing only until S is only what? 1 spring. Correct? So when your wood have reaches T, so imagine I compress to S first, first step. Only 1 spring involved. Notice, when I at S, right, I compress further. I'm pushing 2 springs together. And these 2 springs in this context seem like what? They are parallel. Notice or not? They are parallel. So that means this idea, when they're further pushing that time, it will be kind of harder. Or when the springs are arranged in parallel, your spring constant is greater. 1 spring is easier to push because your compression is less. This one will be more clear. So generally, force versus extension graph enable you to find the spring constant, spring constant is force per unit extension, right? So like I say, beginning part is less stiff, then later on stiffer. So the answer is A lah. So C, no changes, cannot. B, they become less stiff, also not correct. D, lagi not correct, this part. 28. Diagram 20 shows a water tank placed in the space between the ceiling and the roof, and the water tank is connected to a water tap in a house. So what is the water pressure act on the water tap. Okay, water pressure. Now, be careful. Sometimes question they may ask what is the total pressure. If they say total pressure, then you also need to involve the idea of atmospheric pressure. So this one very obvious. You only involve water pressure. So what is the formula for water pressure? P equals to H rho G, where H is the depth of water, rho is density of water here, G is here. So in this diagram, they want you to find the depth. That means from the surface of the water to the tap itself. So it's from where to where? From here to here. So what is the depth itself? So they actually give you from beginning until the lowest base, 6 meters. I want to reach here only, so that means 6 minus 1, right? Okay, so your depth is actually 5 meters only. So you will have 5 times 1,000 times 9.81. And same thing, press calculator. And what is your answer for these questions? Is supposed to be 49050, right? See, 29, what is mean by atmospheric pressure? So in general, pressure is actually force per unit area. So this is a general idea. That means in any solid object, T is force per unit area. But then they want atmospheric pressure, so not so accurate, understand? Then B, pressure difference between high and low altitude, also not correct. C, pressure caused by collision of the gas particle and the wall. This is actually referred to gas pressure. Lastly, D, pressure caused by the weight of air layer acting on the Earth's surface. Yes, this is the idea. I always tell students, generally atmospheric pressure is acting you and me and everything. Okay, it's just that we won't find the difference unless we experience different in height. Example, you go to Genting Highland or you are in a plane, then you may slightly feel the differences, or even you go to the deep sea. Okay, so for information, the definition of atmospheric pressure is the pressure due to what? The weight of layer of air acting on the surface of the Earth. Okay, 30. Diagram 31 shows a manometer connected to the gas supply. So what will happen to the height between the liquid level in both arms of the manometer if water is replaced by mercury? Okay, now, for information, the function of this manometer is to measure gas pressure. But they are using the liquid, so we are using the equation for liquid pressure, H rho G. So in the context of using manometer, this H is the difference of level in this liquid lah. Now I just change the liquid inside the tube, means I change water to become mercury. But do I changes the gas supply? All these? No, correct or not? Okay, so that's why your gas pressure will, or the pressure, how to say, not gas pressure, not necessary. But of course, the gas pressure causes the different in length. Can. Okay, but I ignore the. So the idea here is how your gas pressure is constant, but what is the one that changes is the context of density. Mercury basically high density. If you have high density, G is also constant. Now what happened to your difference in H so that you will have constant value of your pressure? So it's supposed to be less, so the answer is B. So let's say you replace this with a different liquid or liquid which is less dense, like oil. Then they will be the other way around, they will increase. But if let's say question also say I change to a thicker diameter, then there won't be change, right? Understand? Because diameter won't affect the value of H. So that's why something you all need to take notes how to solve these questions. 31. Diagram 22 shows an apple floats at the surface of water. Why does the apple float? So for information under the topic of Archimedes principle, you all have the idea on resultant force as well. So when object is in the liquid, you have the weight and also you have the buoyant force. So generally, if they are float, this means I always tell students, seems like not moving, So that means these two magnitude is same because the net force is 0. So the answer is this lah. A, weight is same at boiling force. Resultant force acting upward not so correct. If acting upward, then they will fly up already. More than that, also they'll fly up okay. So resultant force is 0 Okay. Then the volume. Now, volume apple equals to volume of water display is also not accurate. Okay, because only half of the apple is submerged. So this half of the volume of apple is the liquid displaced. So that's why not correct. Unless the whole apple is submerged inside, then D actually can be considered correct. 32, a racing car is equipped with an aerofoil-shaped spoiler. Which physics principle explain the spoiler function? Okay, so the spoiler is actually inverted aerofoil, inverted aerofoil. So when you all learn this idea is under Bernoulli principle lah. Okay, so aerofoil idea inverted is to produce downward force. If it is aerofoil, the wing of the plane, they cause a lifting force, right? So this is how the spoiler work, where your speed is high, pressure is low, then beneath the speed is, sorry, I write wrongly. On top, your speed is low, and then the pressure is high. Bottom, the speed is high, pressure is low. So the difference in pressure causing a force, and the force direction is from high pressure to low pressure. That's why you cause a downward force. And this is the concept of Bernoulli principle. 33, diagram 23 show a heating element that is found in an iron. The iron works normally when it's applied with 240 volt and given the current is 10 ampere. The length of the heating element is 20 cm and the cross-sectional area is 0.01 meters square. So what is the resistivity of the heating element? So first step, you all need to know what is the formula involved. So the formula of this resistivity is based on the relationship between resistance, the factor affecting resistance. So from there, resistance is directly proportional to length. Resistance is also inversely proportional to cross-sectional area. Then we combine this equation, L surface area. Then we change this sign, we will have R equal to a constant. So this constant, this same like that's this symbol, but we name it as phi, L over A. So this is referred to resistivity. Okay, then they want to calculate, so I already know phi equals to R times surface area divided by length. Okay, so read through the question. Find out all the given quantity. They give me voltage, they give me current, they give me length, L, they give me A. The equation do not have R watt. But why the question give you V and I? Because you also can find R using what? V over I, V equals to IR, correct? Then you sublog 240 divided by 10, you get 24 for R first ohm. Okay, now you have everything. Okay, so you have everything, then you sub lah. But before you sub, another thing is it all are in SI unit. Area 0.01 meter square is meter square SI unit, no problem. But you check what happened to your length? Your length is 28 cm. Centimeter is not SI unit. What is centi? Centi is 10 power of negative 2. Or you generally know how to change centimeter to meter, right? You divide 100. Means you can write 0.28 also. No problem, okay? Whichever idea that you actually understand regarding the prefix idea. Okay, now you press calculator. So once you press calculator, you supposedly to get 0.85714. Okay, so you see, normally, sometimes a calculator can be in standard form or sometimes like this form. So again, it's max part already, you notice or not? But nowadays, teacher also have to explain about the max part because some students, they just do not know how to change to standard form. So you move this dot to this point, so it's 1, right? But then you small number, right, to become a big number. So you see decimal point, that means your power is -1. So it's supposed to be -1. And the unit memang is ohm meter lah, based on the equation. This is ohm meter square, then you divide by meter again. So that's why it's ohm meter. In case paper 2, right, they ask you to do calculation, you need to know how to use this formula. 34, Diagram 24 show a bar magnet is moved with a high speed toward the solenoid PQ. What will happen? Okay, so as you can see, the ends of the magnet that move toward the solenoid is what pole? North pole. So based on Lenz's law, they say what? Okay, when you towards, I want to oppose you. So automatically P will produce north pole. Then the other side will be south pole lah. Then after that, you're supposed to use right-hand grip rule to determine the direction of current in the coil. So I will say our right-hand grip rule got two usage. One is for Lenz's law idea lah. So your thumb will be what? North pole. And then you see the current flow on the coil will face up, okay? If you're north pole the other side, it will face down lor. So next step, you'll draw the arrowhead up on the solenoid. Okay, the current like that. Then you'll complete. So this one you careful that turn to the back, right? So the current to the positive they will reflect this way one. Okay, I say current from here, they reflect here. Come here, they reflect here lah. Easier deflections. Okay, so P north, correct. Reflect to the right, correct. Your idea of this concept is electromagnetic induction, so you induce EMF. Also correct, so your answer will be D. 35. Diagram 25 shows a bulb is connected to a 24 volt of AC power supply through an ideal transformer. And the primary current is 0.04 ampere and secondary current is 0.5 ampere. What is the output voltage? Now, the key words here, ideal transformer. If the transformer is ideal, therefore the output power equals to input power. Well, so power formula, a few so under transformer, we always change the formula for power. I will say physics are very important. VI idea, okay? So output means secondary, inputs mean primary. So we see the information again. I will say you also label on the number on top straight away. Sometimes it's not time consuming. You see, when you can listen to me and you understand what am I doing, you also do the same thing. You all don't just like, I look at the formula lah. Some people, they don't even label S and P. Then when they put in something will be went wrong one. Then this is why the student always cannot get the final answer correctly. Okay, so this 24 is actually input. Okay, so it's a primary idea. So we P. Then this is I, P. This is I, S. Output is also secondary idea. So I don't know this one. Okay. So VS equals to 24 times 0.04. So you see, I just see my PP. I won't put wrongly one. Then 0.5. Okay, then finally your press calculator, you will get 1.92 volts. So this is how you all get the answer. So proceed to question 36. Diagram 26 show electrons are released when the 6-volt power supply is switched on. So what is the process that occur at the cathode? Okay, so this is under electronic, the topic for electron. So notice or not, you have this filament. So your filament is basically being heat up. So when they heat up, what happened to the surface of this cathode? They will emit electrons. So this process is actually called thermionic emission. This idea is called thermionic emission. So we look at the option A, B, C, D. So which one is the correct answer? B, thermionic emission. 37. Diagram 37 show a circuit used to produce full wave rectifications. So which arrangement of diode show full wave rectifications? So first step, I always tell students, the full wave idea, when you arrange your diode, right, make sure the diode which are parallel, they are in same direction. Like this one, up, up, same direction. Or once the opposite, memang it won't work already. Opposite, then they won't work already. Okay, then next, they always have a pattern one is like this, okay, if your battery is outside. Or you try to put in, I use the arrowhead idea, easier to draw. Means the triangle, okay, but if I want to draw finish also can. So I put inside. So how this full wave idea work? When the current is start with positive terminal on top. So they will find the one that forward bias. So this is P-type, M-type. So they will choose this diode. Then after that, they will go through here. Then the current must go one cycle. So they will choose this parallel punya diode one. Okay, so you complete a cycle. But then the next half cycle, they will actually change to become negative positive. So you from bottom pull up. Then you choose this one. You know, they are forward bias. Then again, they will choose this pull up. And then you complete a cycle. So that's why A is the correct idea. D, you see this diode is opposite direction than the other two. So that's why it's finally not work one. Number 38. What is radioactive decay? So process of releasing energetic particle, not correct. A process unstable nucleus to become the stable one. Yes. And then what is this process of splitting of large to the small? Actually, the terminology used wrong. We do not have the word large, small, small, large. Okay, it's heavier, lighter, lighter, heavier. Okay. Memang D also not related at all lah. So all this is not correct. Okay, if they use the heavier to lighter one, this one is idea of nuclear fission for C. 39. Diagram 28 shows the diffraction patterns of electrons through a thin layer of graphite. If the flow of electron is replaced by flow of proton but move with same momentum, what happened to the distance? Okay, so for information, the diffraction pattern, the fringes idea is affected by the wavelength. So this idea is on the diffracted fringes due to the electrons idea. So they actually will involve this de Broglie wavelength. De Broglie wavelength formula where lambda equals to Planck constant divided by momentum, or sometimes we change this momentum into mv idea. So they already say this is constant. If this is constant, that means Planck constant is memang constant. So do your wavelength change? Your wavelength also no changes. So if wavelength no changes, that means your pattern also will no changes. So the answer is C. Okay, then last questions. Diagram 29 shows cathode is illuminated with monochromatic light. What will happen if the light intensity increase? That means brighter. So generally what happens is if photoelectric effect occurs, you shine with high intensity, they will increase the number of electrons. But if let's say photoelectric effect not occur, even you increase the light intensity, nothing will happen as well. Okay, so what is the best answer? The reading of galvanometer will increase, number of photoelectron increase, the frequency decrease. Wrong. Kinetic energy not correct. Kinetic energy refer to frequency. Okay. The best answer is basically B lah. A, if based on English, supposed to be correct. Again, you see they always didn't change correctly. You see BM, galvanometer decreases. Wrong. So by right, English version should be in decrease. Okay. So that's why A is not correct lah. Okay. So I hope that you're alert with all the idea given. Or sometimes you find out some problem, right? You read the BM version also. Because sometimes who knows, really SPM got some mistake or ralat, okay? But you cannot leave it blank, you still need to give an answer. So you also sometimes can counter check with BM version. Like this question also happen, right? Who knows, you all encounter some mistake in questions. So you still need to answer. So this is how I detect lah. B is the best one, the correct one, accurate one. Yeah, so we have done with this SBP 2024 paper. So I hope that you benefit from all the explanation given by the teachers. See you again. Bye-bye.